Welcome, viewers, to the very last video in our Unit 4. Today we're going to be having an introduction to triangle proofs, and congruent parts of congruent triangles are always congruent. And that's what the CPCTC stands for here. Can't write in white. That doesn't work. Okay, so we are going to learn a little bit about two-column proofs as we're going through this. And I know it looks a little different and you've never seen this before, and that's perfectly fine. Okay, so let's go ahead and look at the given information we have here. Excuse me. So write a two-column proof for each. Given yx is congruent to yz. Okay. What is the reason that we know that? We know that because it is given to us. Now let's mark that on our diagram. Yx is congruent to yz. I forgot my little bar here. Okay, perfect. Let's look at the second piece of information. And that is angle XYW, this angle right here, is congruent to angle ZYW, this angle right here. And why do we know that? The reason is it's given. Now, the next thing we are told is that we have to prove that this line in red here, XW, is congruent to ZW. Okay, and how we're going to do that is we're going to prove the two triangles are congruent. Then once we know both the triangles are congruent, then we know that all their corresponding parts are congruent. All their angles, their corresponding angles are congruent. All their corresponding sides are congruent. We know that about congruent triangles. So how do we do this? Well, let's look at the information that we have. You see how we have this third piece of information that's hidden from us. And we've talked a little bit about hidden information. We have a side that they have in common, both triangles, right? So I'll put 2 marks on it because I've already used the 1 mark. Well, that is, we know that's the same in both the triangles, and that's called the reflexive property of segment concurrence. And all that means is if it's one measure in one triangle, it's the exact same measure in the other triangle. We know that because they're the same. So now that we have that information, the hidden information written down, we have enough information to prove the two triangles are congruent. You see we have side, angle, side. So we can prove the two triangles are congruent by side, angle, side, SAS. So let's see if we can write the two triangles and say they're congruent. Okay, so triangle XYW is congruent to triangle ZYW. And we know that by SAS, side, angle, side. So now we can write our last statement that we're trying to prove. And what you're trying to prove should always be last. Why do we know what we're trying to prove? We know it because the congruent parts of congruent triangles are always congruent. And I'll go ahead and erase what's up here, just so we can see. Those two triangles are congruent, then that means that side is congruent to that side is congruent to that side, this side is congruent to itself, this angle is congruent to that corresponding angle, this angle is congruent to its corresponding angle, and so on. Let's move on. Let's look at the second proof here. It's the bow tie problem. All right, first and second piece of information, go ahead and write them in as given. All right, as you're writing that in, I'm going to go ahead and mark my diagram. IJ is congruent to LJ, and HJ is congruent to KJ. All right, we do know one other piece of information, and a lot of times we miss this, but if we miss it, we can't prove the two triangles are congruent. See these vertical angles? We know vertical angles are congruent. So we can go ahead and write those in. Okay, so IJH is congruent to angle LJK. And we know that because vertical angles are congruent. So now that we have that information, we've got SAS. We've got SAS. So we got to name the two triangles. So triangle IJH should be congruent to triangle LJK. And be careful about how, you see in step 3 they were angles, and step 4 they're triangles. Now we're saying that the triangles are congruent by SAS. Now we can prove any of their corresponding parts are congruent. So we want to know IH, where's IH? IH, that should be congruent to LK. Because now we know that the two triangles are congruent. And we know they're congruent, so therefore all their corresponding parts of congruent triangles are congruent. All right, look, we've got another bow tie problem. See if you can figure it out and come back to me. Press pause. All right, here's your proof. The first two statements are given. The third one is vertical angles, just like the last problem. So then we know they're both, the two triangles are congruent by side angle side. And then we can say all their corresponding parts are congruent. Moving on to number 4. So go ahead and write in your given information. See if you can get the second piece of the given information there. All right, so I put the information on the form here for the first two, the statements and the reasons. But let's mark the diagram. So we know that angle C is congruent to angle A. But how do we mark the diagram for BD bisects angle ABC? BD bisects this angle. ABC. It cuts it directly in half, which makes this angle congruent to this angle. Okay, perfect. So now we can fill that in. So we can just write that those two angles are congruent. And how do we know that? That's just the definition of an angle bisector. Bisect means to cut directly in half. Bi means to, sect means cut, bisect. Next statement. We know that we've got another reflexive property information here. That side should be the same measure on both triangles. Now technically it's the reflexive property of segment congruence, but if you just write reflexive property, that is perfectly fine for now. Now we have enough information to prove the triangle is congruent by angle, angle, side. So we can write that out. Triangle ABD is congruent to triangle CBD. And that's congruent by angle, angle, side. And now our last step is proving what they're asking. AB is congruent to side CB. And we know that because all corresponding parts of congruent triangles are congruent. Moving on to the last section here. In quick review, if you have at least two sides congruent in a triangle, it's an isosceles triangle. It's equilateral if all three sides are congruent. So every equilateral triangle, you can call it isosceles, but more specifically is also equilateral. So let's look at an isosceles triangle. It's composed of two legs. So those are the two sides that are the same measure, and then also a base. The third side is the base, and it could be longer or shorter than the legs, depending on the triangle. Then these two angles that are opposite the legs are congruent because those two legs are congruent, and that's the base angle theorem coming up in just a second. The third angle is called the vertex, and it might not be at the top, it could be at the bottom or on the side. I mean, these things are always all flipped around. That's the vertex angle. So if two sides of a triangle are congruent, okay, like so, this triangle we were just looking at, then we know that the angles opposite them are congruent. That's the base angles theorem. So what's fascinating and fabulous about this is that I'll just draw myself a triangle, and I'm expecting you guys to be drawing what I'm drawing. If you know that those two sides are congruent, then you can say that these two right across from them, okay, those two angles are congruent. So if AB is congruent to BC, then you know that angle A is congruent to angle C. And it goes the other way around too. Sometimes you know the angles, so you know the sides are the same measure. Sometimes you know the sides, so you know the angles are the same measure. And so that means the converse is also true. So see if you can do the two examples at the bottom, and then press pause and see if you can try them. I'll give you a little head start here. Those two sides are the same measure, which tells you that those two angles are the same measure. So you can set them equal to each other. So you would set them equal, do the problem, solve it, push pause, see if you can figure out the third angle, because you know all three angles have to add up to 180 degrees. So push pause and try it. I got x is 48, and then y is 180 minus 55 minus 55, because those two angles are each 55 degrees. They should be the same. And then that's y, so that's 70 degrees. Oops. Take it. There we go. All right. Now, I can't just, I can set x equal to 9y, but we're missing some information here because we have two variables. The other piece of information that we know, though, is that the third angle is 90 degrees. So, which makes x equal to 45. Because if that equals 90, and the other two angles have to add up to 90, and they're the same, they each have to be 45, which means x is 45, so then that also means that 9y is 45, so you divide both sides by 9, you get y is 5. So those are your two answers right there. All right, I think that's it. Peace out.